This is a continuation of C programming language tutorial. In today's class, we are going to discuss about unions. Hi, hello everyone. Welcome to this channel Easy Engineering. If you are watching this channel for the first time, watch this video till the end. And if you like this video, then do like, share and subscribe. Let's get into the video. First, let's see what is the definition of union, and then syntax along with some example, right? So, unions. What is the definition of union? It is a special data type that allows storing different data types in the same memory location. See, we have known about structures, right? In previous classes, somewhere we have seen about structures. It is almost related to structures, but I will say the main difference between structure and union also in this video. So, see, it is a special data type that allows storing different data types in the same memory location. See, structure. There is a definition of structure also in union. See, this is the definition of structure. You all know that, right? It is a special data type that allows storing different data types. But in the same memory location is the extra part in union. That is the main difference between structure and union. So how means, let me explain. Yes, you all know this is a memory. Yes, you all know this is a memory, right? So in this, a structure will be created, but that structures, no, not like this, but there will be a structure like this, right? It will be containing int, char, some more int, float, like that. So this int will be having some memory address like this somewhere else, and this float will be having here, and char will be having here, and another int will be having like this. They are not continuous. They are not in a continuous manner. They are like distributed in the memory, right? They are not continuously allocated, but they are distributed. They are allocated randomly, like here something, like here something, like that. They are allocated randomly. So the memory addresses will be much different in structure variable. But in the case of let me erase all the structure methods, and yes, now that is structure, right? But now this is union. See, here we are having union. Likewise, we are having int, char, float and another int. See, but now we are having this int variable here. This is int variable, and all the values are not stored like this, but see, they are like see, in this, which is having the highest storage. See, if we are having, let's see in this example, see, we are having int, float and char. As we all know, int takes 2 bytes, right? And float takes 4 bytes. As char takes 1 byte. Which is highest in this? Float is highest, right? So in the memory, this highest number of bytes will be allocated for this union. So here, if we wanna use any one variable, so if we wanna use int, it can fit in it, right? If we want float, yes, easily we can take this total memory which is allocated for this union. And if we want char, so we are just taking a small amount because it is 4 bytes, right? It's 1/4. The char is 1/4 part, so we are taking somewhat. So that's the reason in a structure all the variables will be allocated and they are allocated randomly, but in this union the highest storage, the variable which is having highest storage will be allocated, and that memory will be used whenever another items or another variables are used. Okay, that memory is used whenever those are accessed, right? So that's the main difference between union and structure. Okay, and then after this, let's see the syntax. See, this is same as a structure syntax. See, in the place of struct we are using union, and this union name is called as variable name. We all know what are the rules to create a variable, right? See, this flower braces is opened and closed along with semicolon, and inside we are having these variables, right? This is the variables along with the data types. This is the syntax, same as structure, but only this keyword is changed. This keyword is union, that keyword will be struct. And now let's see the example, right? Let's know about this example in code editor. Let me copy this and go to code editor. Let me paste it. Yes. Now this is a mandatory line, as you all know, and see, here we are creating a union variable, union keyword along with variable name, and inside we are having integer variable, a float variable, and a string, right? And after that int main is there, from where the execution starts, and here we are just creating a object for data union, right? Union name and object name, right? After that we are assigning values. Data dot I is 10, and we are just printing it down, right? We have printed it. And data dot f 18.5, we have printed it, right? So that's how to access the members of data, members of union variable. And let's see what we will be getting after we run. The expected output will be like data dot I equals to, what is it? It is 10, right? Data dot I equals to 10, data dot f equals to 18.5. That should be the output. Let's see what we will be getting. Yes, data dot I equals to 10 and data dot f equals to 18.5 and 5 zeros. That's because a float variable, every compiler by default takes 6 places after the decimal point, right? That's the reason we are getting 5 zeros after that single 5, right? So I think you have understood this example, and after this we are having the differences between structure and union, right? See, both are equal. You have seen like both syntax is equal, example program can be used equally, but only the keyword is changed, like struct and union, right? So let us see the other differences between structure and union, right? So those differences are, see, here we are having feature, struct and union, right? Let us see in the memory allocation. What is the difference in memory allocation? See, structure allocates memory for all the members. See, if in a structure, consider this as a structure for some case, okay, yes, consider it as a structure, okay, then it allocates memory for all of this. Means it contains 2 bytes, it contains 4 bytes, and it contains 1 byte. Combinedly, it will take the allocation in memory and stores these values inside the, means it contains how much, it needs 7 bytes to store, right? It allocates memory like that. But union, what does union do? It allocates memory equal to largest member only. Yes, I said right here. What is largest member? It is float, right? So it takes 4 bytes, but structure takes how much? 7 bytes, right? Because 1 plus 4 plus 2 plus 4 plus 1, which is 7 bytes. See, the difference is 3 bytes. Okay, then that is the difference in memory allocation and member access. All members can be accessed simultaneously. Means in structure we can access all the members at one time. Okay, we can access all the members, like we can access int, float and char at a time. But in union, only one member at a time holds a valid value. That's because, see, in union, if you want to just write, yes, in union, if you want to access float, then the 4 bytes will be allocated for float itself, right? So where will this int go? That's why only one item will be allocated and used at a time, okay, in union. But in structure, all members can be accessed simultaneously. And the another difference is size. The size of the structure is same as the previous one. The size of the structure will be sum of all the member sizes, because it allocates memory for all the members. But in union, the size of union will be size of the largest member, because it allocates memory equal to largest member only. So that's the reason the size of union will be size of the largest member in that union. Okay, that is another usage. These all usages are interlinked, right? Means these all features, these differences are interlinked. Like, see, memory allocation, it allocates memory further, and member access, it is interlinked with memory allocation, right? And size, it is also interlinked with memory allocation. These all three are the differences which are having equal importance. Okay, then next comes the usage. What is the usage of structure? That means when we want to use all the members at a time, like when we want to use, like, see here in structure something, we are using like that student ID. We are using that student ID and marks, average of marks, and his name or section, those all at a time, right? If a user wants to get all those details regarding a student, he need to get everything at once, right? Student name should be there, his father name, his roll number, his percentage, his attendance percentage, etc. All should be there at one place. But if only his marks present there, for whom these marks are considered, right? So structure will be useful when you need all members together. Here in this case we need all the members together, so that's the reason we are using structures. In union, when you need only one value at a time, that means if you go to an ATM machine and you wanna first you will be getting a screen like enter pin, like that, right? Only we will be getting one, right? Enter pin. First we are going to get welcome message. After that, if we click something, get started or something, we will be redirected to the page which is taking input as our pin or account number, something, right? So that's the reason we are only using one. See, here we will be getting welcome or account number, like that. Why all are not accessing at one time? See, we are only accessing only one variable at a time in this. That's why first we are using a string variable which is giving you a welcome message, right? Welcome message. And after that is erased, we are using a account number or something like that. Account number or something like that. After that is erased, then we will be redirecting to our history, right? So why this is useful means to save the memory, right? To save the memory, unions are used because only one type will be used at a time. So that's the reason we will be using strings, not strings. We are using unions, right? Yes, usage is that. And example use cases. What are the examples for struct and union? See, in struct, complex data like records. In struct, there will be complex data types. Data records, like, that's because it can store so much data once, right? It can store every data. So complex data like records can also store complex data, means you can know, like, complex data types means different data types like int, float, char, string, something like that, double, arrays, like that. All can be stored at a place which is known as struct. Then for union, variant data like packets type conversion. That means, see, we are using only data packets. That's because in the data packets only similar data type will be stored. That's the reason we are only storing the single variable once in union. So that's all for today's class. If you have any doubts in today's class, do comment down. I will be replying it as soon as possible. And if you like this session, do like the video and subscribe to this channel if you feel this is useful. Thank you. That's all for today.